we have enough money to use that color, but not to keep the bathrooms.
Number 1, the mean age of 5 people in a room is 30 years. One of the people who is 50 years old leaves the room. The mean age of the remaining 4 people. Okay, so let's remember how this works. We had 5 people. One of them is going to be 50 years old. So I'm going to kind of do this using some variables. A, B, C, D. Those are the 4 people in the room, and then we have one person who's 50 years old. If you divide that by 5, you're going to get 30. Going to do a little bit of math. 5 times 30 is 150. 150 minus 50 is 100. So really what we're saying is A plus C plus A plus B plus C plus D. That's equal to 100. Okay, if I take the average of these 4 people, I'm supposed to just divide everything by 4. Giving me the average equals 25. Unless I divided wrong. 3 times 50 minus 50. Sorry, 5 times 30 minus 50. Okay. That's good. Number 2. I hope you get that question. Question 2. A sample was taken of 20 employees at a large company. The following are the salaries for the year. For convenience, the data is ordered. Oh, thank you. What is the median salary of the 20 employees? Okay, so this is an order. Do we have an odd number of measurements or an even number? Even. So we have an even number of measurements, even number of observations, even number of, are these employees? Did I read that right? Employees. Right. If the list is in order, then the median is the average of the 20 and 21st employee from the bottom, right? And this is basically why the list is in order. So you can do this really quickly. The 20 and 21st are 47 and 49. So the median is equal to 1/2 of 47 and 49. You're not going to do that for me? The median is 48. Mm-hmm.
It's 10th and 11th.
Sorry?
We need 10th and 11th.
10th and 11th, yeah. 10th and 11th. 11th. Okay. That's question 2. 3. Nothing shocking yet, right? The box plot below is the birth weights of a sample of 160 infants at a local hospital. What is the approximate median birth weight? Maybe I should do this. Let's get to that. And let's screenshot it. This is actually one of my favorite features of the program. Yeah, right there. That's awesome. Okay, so if we're looking at this and we want to decipher, just so you remember that this is the minimum. This is the Q1. This is the median. This is the maximum. And of course, if you have anything out here like that, that would be an outlier.
And wait, sorry, the outliers are found with the Q3 plus 1.5 IQ,
That would be how to find where the limit of the outliers would be.
would that be the max?
Not necessarily. The max is an observation that 1.5 IQR plus Q3. That's not necessarily one of the observations in the data list. Okay, so now that we got that, we can just kind of figure this out. Where is my median? Yeah, it's pretty much 110. I assume those are, no, I can't assume they're ounces. Oh, it is.
So the outliers will always be like further from the maximum.
They'll always be separated. They'll always end up as being like a little box or an asterisk outside there. So that would be an outlier on the bottom, on the low side. So maybe this right here, it says max. What it really should is the maximum non-outlier. And this right here is going to be the minimum non-outlier. Yeah.
The one above the median is the Q2.
It's Q3. Where did that go? I thought I wrote it. I never wrote it? Oops. Okay. Any further questions on this? You could also get the IQR from this if you wanted to. The IQR is approximately, let's call that 125 and 105. So IQR is approximately equal to 125 minus 105. It's 20. It's approximately the IQR. Yeah.
I forgot. Can you find the mean from a box plot?
No.
Okay.
You can approximate it based on shape and median,
Okay.
but that's the best you can do.
Okay.
Also, you can't tell the number of observations. Okay. Maybe I should write that down here. You can never. From a box plot. That seems to be a favorite question of test takers, is to give you a box plot and to tell you which one has more observations. Or they'll have something based on an observation. You can't tell how many observations. Let's go to 4. Okay. Let's screenshot this again since it works so well. Okay, so we're looking for the maximum number of burglaries in the year 1980. In the year 1988. So just to kind of give you an idea, 1988 starts here and ends here. So basically we're just looking here in this highlighted region. Where do we have the most burglaries?
Around the end.
Yeah, it's basically that huge peak, right?
Yeah.
That's, you don't need to be in AP Stats to know that. I hope my algebra kids would know where the maximum is here. The maximum, of course, is that gigantic peak right there. That's the maximum in 1988. that maximum number of burglaries looks like about, oh, I don't know, 35. Burglaries.
So, right,
Yeah.
these questions are similar.
Not necessarily.
Harder, easier.
For just additional practice. Question 5. Zooming along here. We're going to use that histogram, and yeah, I should screenshot that histogram too. Okay, and amount of money. These class widths look like about 10, so this is somewhere between $0 and less than $10. There was about, that looks like 60, right? If I remember this question correctly, you're probably going to want to estimate how tall each of these bars are. So if I remember, so this is, looks like about 60, right? This looks like about 44, 43? Let's say about 43. This looks like about 20. This looks like about 7, 1, 3. Oh, there's, looks like 1. And there's supposed to be 136 students, right? So how many is this? 103, 133, 1. Is it 135?
I think so.
23, 23, 30, 31, 2, 3, 4, 5. Oh, yeah. Not bad. I mean, I'm missing one student somewhere, I think.
Probably 61.
It's 61
Yeah,
instead of
it was
60 because it was a little bit higher.
It looks like 61.
Yeah, this was on the
See, so let's say on the test, like, we made that mistake and we wrote 60.
It shouldn't, if you're off by a couple, it's not going to change this. Okay, so the question here is, the histogram is of the data is collected. Describe the distribution shape and approximate median. Okay, shape. This is definitely right skewed. This is all for question 5, right? Shape is right skewed. Right skewed. What about the median? Well, the median, since there are 136 students, the median is the average of the, let's see, 136 divided by 2, 50 plus 18, 68.
How did you do that?
68th and 69th student. So we just need to find out where the 68th and 69th student is.
20.
Yeah, the 69th and 70th student are somewhere between 10 and 20. Okay. Both the 68th student are in the, what do we call this, the class 10 to 20. Okay, so a good estimate for the median is any number in between 10 and 20, right? Probably you would say 15 if you had to pick a number. An estimate for the median is any number, or is a number between 10 and 20. You know, my typing skills are really bad today. Yeah, you would probably say 15. Yeah,
Right skew, left skew.
sure. Right skew is... Well, in my experience, skew tends to be the opposite of what students think it means. So skew really means is, let's see. Well, skew really means where is the mean in relation to the median. Okay. And in a distribution like this, the mean is going to be greater than the median, hence the right skew. But if you want to take a look visually, you just want to take a look. If the peak is on the left, then it's right skewed.
Because you left the median?
No, I mean if the peak is on the left side of the graph,
Okay.
then you have a right skew. And if the peak is on the right side of the graph, you're going to have left skew.
And right skew has the same definition as positive skew.
Yeah, right skew and positive skew mean the same thing. Good questions. Good review. All right, we should look at 6 too. Six says the percentage of students with under $10 in their possession. Well, how many students have $10 in their possession? Yeah. 61 students have less than $10. Okay. So, percentage. Thank you. That's going to be 61 out of 136. You did say 44, right?
Yeah.
Yeah. Ooh. 44.85. Okay, chapters 7, or questions 7 through 9 is about the normal distribution, but it's not really about the normal distribution. These ones are 68, 95, 99, 7 rule, right? So let's take a look at this. We have a mean of 8.1 and a standard deviation of 0.1. Okay, so for question 7, what proportion of the bars weigh less than 8 ounces? The probability that a bar weight is less than 8. I like the way that this looks like what we're doing now in class, or what we just finished up. That's handy. Okay, this is going to be equal to the proportion of z-scores that are less than 8 minus 8.1 over 0.1. And that says the proportion of z that's less than -1. So you draw that z-score. You shouldn't need to use a calculator for this one. That's not the intention of this question. There's 8.1 with a z-score of 0. 8 is over here with a z-score of -1. So you're supposed to have this area memorized.
13.
And just to help you, remember that the middle area here is 68%.
And then the other one is 95. And then the other one is 99.
So this is about 68% in here. That means these two tails together are 32%.
So the other one is
So this is 16. It's actually a little less than 16, but we're just worrying about approximating. So it's approximately 16%. Okay. Proportion between 8.2 and 8.3. Again, we're going to do this by converting to z-scores. We're going to have 8.2 minus 8.1 divided by 0.1 is less than z is less than 8.3 minus 8.1 over 0.1. Okay. And that, I think, is 1 and 2. Well, golly, how do we do this? Let's take a look at the curve between 1 and 2. That is not a good normal curve. This is 8.2 with a z-score of 1. Do you remember the area to the right of that?
That looks
oh, 16.
0.1, yeah, 16%. Approximately. So this area is 0.16, right?
so that's just for first.
Yeah.
So what would approximately be the area after the first standard deviation? It's like really small, right?
After the first standard deviation? Third? Yeah, 0.000115, I think.
Okay.
Very small, yeah. So this yellow area, that is 0.16, right? Okay, let's take a look at the next one, which is 8.3. 8.3 is going to be another standard deviation away with a standard deviation of 2. So do you remember? I don't know what I was saying right there. Do we remember the area outside here?
Point
0.025? Should be 0.025. That's 0.025, right?
You got 0.025 because you have 5% left for both sides, and then that's the 5% right there.
Yes. Just like that. Okay, so the question here is going to be, what is the area here between 8.2 and 8.3? Of course, you would just subtract this. Point 135.
Yeah.
Okay. Okay, that is that. Let's take a look at question 9 then. I think we're gonna stop at 9, or maybe we should go to 10. I'm not sure. Let's see how quickly. We can expect 68% to be within one standard deviation, right? 68% are within one standard deviation. Therefore, 68% of candy bars are between, that is 8 ounces and 8.2 ounces. Okay, last one we're going to do, number 10. We have a soft drink machine can be regulated so it discharges. Ooh, what an ugly word. Discharges an average of mu ounces of cup. If the ounces are normally distributed with a standard deviation of 4, where should we set our mean so that we only overflow 2% of the time? Okay, this is an interesting question. 2% of the time. This question is chapter 7 now, isn't it? 2% is not one of the ones you're supposed to have memorized. Right, that's decent at least. Okay, so let's see. We want 8-ounce cups. 8 ounce? 6 ounce cups to overflow 2% of the time. So this area is 0.02. We want to know, what should this mean be? Well, in order to do this, we're going to need the z-score first. Let's get a z-score. Z-score. Z is equal to the inverse norm of 0.98. Let's get that inverse norm. F6 shift V. Oh, it worked. Inverse norm of 0.02. Oh wait, why did I do 0.02? 0.9. Oh, isn't this the same as I'm gonna get 2.05, right? Are you comfortable with that? I put the wrong number in. But I should just get the same thing. 2.05. It's equal to 2.05. Well, 0.02 is the area to the right, so the area to the left is 0.98. But because the normal curve is symmetric, you could do 0.02 and get the same thing, but negative. I'd like to finish this up. So we have the z-score is equal to the measurement 6 minus the mean over the standard deviation of 0.4. 2.05 is equal to 6 minus the mean over 0.4. And you know, I set my calculator to do this for me. Let's see. Yeah, that's right. So the z-score is 2.05. X is unknown. The mean was no. The X is 6. The mean is unknown. Standard deviation is 0.4. And the mean is 5.18. That's it. Thank you very much. We are meeting after school today. It'll be online, yeah.
Did we tell you about Pat's deal about the all A's? We get all A's on all the tests.